Hi, I'm Emma, Environmental Specialist at Ecochain, and I'm going to show you how to model your transport in a scalable way. This video is meant for people that already know how transportation works, so you already know what a ton-kilometer is and how you can find the references. If you don't know this yet, I would recommend watching those other videos first. This is actually quite an important topic because, as we know, the unit of transport is ton-kilometers, but this is actually a bit of a intransparent unit because the amount of weight that you're transporting and the amount of kilometers are combined into one number, and you cannot easily pull them apart again without knowing one or the other. But sometimes actually that would be very convenient. For example, when you're using different amounts of the same material, it would be really nice if you could just scale the amount of ton-kilometers based on the amount of kilograms that you're transporting, or the amount of mass that you're transporting. Because probably if you have the same material, then the transportation distance is going to be the same. So we could keep that one constant, and by modeling this in a scalable way, scalable by mass, you could actually prevent having to go to Excel every time and exactly calculating how many ton-kilometers you need. So in this video I'm going to explain to you how to do just that, and we're going to use the t-shirt demo for this. So you can actually try out everything I'm doing yourself, because you will also have the t-shirt demo in your Mobius account. To show you how to do this, I'm going to model the transport for a certain product, and in this case that is the t-shirt cotton black. So let's open that product and let's see what materials are in there. So this product actually has two main materials in there. It has the cotton fabric black in there, and it has the packaging in there that we see over here. I'm going to model the transport for these two materials in a scalable way. To do so, we're going to go to the object library and we're going to make our objects separately. We're going to start with the plastic packaging. So I'm going to add a new object, and I'm going to call my object transport from supplier plastic packaging. Okay, so what we want to do is pull our transport, the ton-kilometers apart, so that we have one place where we can fill out the distance and one place where we can fill out the amount of mass that we're transporting. How we're going to do that is by giving this top layer, we're going to give this the unit kilograms, because we want to model the transport per kilogram of packaging. So I'm calling that 1 kilogram of transport from supplier plastic packaging. And what I can do now is add a sub-item that actually holds the exact amount of ton-kilometers that 1 kilogram would be traveling. So let's add a sub-item. So I'm going to add some truck transport, because this material is transported by truck. And then we have to calculate how many ton-kilometers we need to fill out. So for that I have an Excel that I will pull up. So in this Excel I built like a small model for calculating the amount of ton-kilometers. So here I'm going to fill out my weight. So in this case that is 1 kilogram, because I want it to be scalable per kilogram. This amount of kilograms obviously needs to be divided by 1,000 in order to arrive at the tons that I need for the ton-kilometer. Then I need to fill out the transportation distance. So in this case, let's say that this packaging is traveling like 150 kilometers by truck. Okay, so now we got the amount of ton-kilometers that we needed to fill out in Mobius from here. So I'm just going to copy this and paste it into Mobius. And now we have a building block that represents 1 kilogram of plastic packaging transported for 150 kilometers. What I can do now is go to my product, the t-shirt cotton black, and I'm going to just add this to the plastic packaging. And let's see, we actually have 0.04 kilogram of packaging, because that's the amount of granulate that's in there. So I'm going to add the sub-item, transport from supplier, this one. Here we go. I have it per kilogram, well I have 0.04 kilograms. And so now you see that Mobius actually scaled the amount of transport, because before we had 0.15 ton-kilometers for 1 kilogram, but now we have way less, so we also have a way smaller number here. So here you see that this is really convenient in scaling your transport in a relatively easy way, because I can now add this sub-item to every product that holds the packaging and just adapt the amount if that's necessary. And I have my transport. So that's super nice. So now we're also going to model the transport for the cotton fabric. And what you see here is that this cotton fabric is actually modeled per square meter. Well, of course, I can also make scalable transport for different units than just the weight. So I can also do it for an amount like square meters or things like that. So let's do that. I'm going back to the object library. And I'm going to create a new object for transport. So I'm going to create transport from supplier, cotton fabric black. Okay. And now we need to define the unit. Well, in this case, we would like to model it per square meter, because then it is exactly the same unit as how we modeled our material. So let's make this square meter. And now we can do two things. Either we can now calculate the amount of ton kilometers per square meter and put that directly under this layer. What we can also do is make a sub layer in between where we state the mass of the square meter. And I think this is the most transparent way to work, and this is also very convenient for yourself to be able to look this up later again to see if that's correct. So I'm going to add another sub item. I'm going to call that transport from supplier cotton fabric black per kilogram. And let's say now I need to fill out how many kilograms I have per square meter. So let's say that's 0.6 kilograms. I call this like this. And now I can add the amount of transport below. Let's say that my cotton fabric is transported by truck. So I'm going to add some truck transport. And we will calculate the amount in a bit. So I'm just going to fill out 1 for now. But let's also say that our fabric is also transported by ocean ship. Let's also add that. Put in 1. Now we can start calculating what actually the amount is of ton kilometers that we need for this amount of weight. And so for 1 square meter of fabric. I'm going to pull up the Excel again. Let's fill it out. So we have 0.6 kilograms. And let's start with truck transports. Let's say that it's also transported for 150 kilometers by truck. So I'm going to copy this number now and put it in Mobius, because this is the amount of ton kilometers we need per square meter. Let's put it in. I'm going to paste that here. And then we go back and we start calculating for the ocean ship. So we still have 0.6 kilograms, but now let's say that we have 15,000 kilometers. So then we need 9 ton kilometer. Okay. Let's put that in there. That's great. So now we have modeled our transport for 1 square meter of cotton fabric black, which is equal to 0.6 kilograms. And we can add that to our product. So we're going back to our black t-shirt. And we're going to add this to the material. Transport from supplier, cotton fabric black. Where are you? Here. And then we have 1.2 square meters, because this material has 1.2 square meters of amount. So I'm going to check this now. And yeah, now you see that you have 1.2 square meters of transport. And so this you can easily scale to any other amount of fabric if you have any other amount. And this makes the transport modeling way more efficient and useful, and actually also more transparent, because you can exactly see what amount you have used. In this video you have learned how to model your transport in a scalable way for a certain amount. If you want to know more about this topic, you can always look up our help center or get in touch with us via the chat. Thank you for watching this video, and good luck with modeling your own transport.